So in part C, we are given the angles between the beam and the normal for various layers in the two models. In part 1, we need to determine an expression for theta 4 in terms of the incident angle NA and NB. So what we can do here is we'll write up Snell's law. So what we know is that n times the angle made with the normal in a given medium will have to remain constant here. So what we can say, for example, is that n air is times the sine of the incident angle will have to be equal to n water times the sine of theta 2. This will have to be equal to nm times sine of theta 3. And this will have to be equal to nb times sine of theta 4, all in model B. What we need to consider now is the two ends of this equation. So we can rearrange this for theta 4 divided by nb and take the arc sine. So we get that theta 4 is the inverse sine of NA over NB times the sine of the incident angle. And then in part 2, we need to rank the angles from the greatest to the least, with 1 being the greatest. And if they're the same value, then we need to give them the same ranking. So, well, which angle is going to be the greatest? The angle that will be the greatest will correspond to the one with the lowest index of refraction. And well, if we think about it, the lowest index of refraction will be in the water. So that will be theta 2. So this will be the smallest one. And then we can consider theta 1 and theta 3. So theta 1 in model A is found in model A is the angle that makes in NM. And theta 3 is the angle that is made again in NM. And then we have theta 4, which is made in the most bottom layer. Now we know that the most bottom layer has the highest concentration, that has the highest refractive index. Therefore, this will have the smallest angle. And as we have seen, theta 1 and theta 3 will have to be the same because they're in the same medium. So NM and MM. So they have the same refractive index, therefore their angle has to be the same as well, as the incident angle in both cases is identical. So I've kind of already explained the appropriate physics principles. However, we can briefly write down that theta 2 is largest because water has smallest refractive index. Theta 1 is equal to theta 3 because they're in the same layer, so same layer slash same refractive index, therefore they must be the same. And theta 4 is the largest. Theta 4 is the smallest because the layer has highest refractive index.